Alright, so today let's take a look at writing equations of parallel and perpendicular lines. So first of all, let's just get a little refresher here of what parallel and perpendicular mean geometrically. So if I have, let's say, a line that looks like that, a line parallel to it would be one like this, right? A line that will never touch it. They run forever in the same direction. Now, perpendicular means a line that intersects a given line at a right angle. So something like that, right, where these two lines meet at a 90-degree angle there. That's perpendicular. Right? Now, in terms of writing equations of perpendicular lines, what we need to look at are slopes. Right? So if I've got two lines that are parallel, they will have the same exact slope. Right? If two lines are perpendicular, they will have opposite reciprocal slopes. Yeah. I'm still working on this pen. Right? So what is an opposite reciprocal? What does that even mean? Right? So if I give you a slope of 2/3, right? Well, it's opposite reciprocal, right? So opposite means take the opposite sign, right? So this was positive. That means my new slope will be negative. And then the reciprocal part means flip the fraction. Okay, so this was 2/3. The reciprocal will be 3/2. Right, so the opposite reciprocal of 2/3 would be negative 3/2. So another example, let's say I give you negative 7/4. Well, its opposite would be positive. The reciprocal would be 4/7. Right? How about something like 2? If I give you just the slope of 2, well, we have to think about that in terms of a fraction. Right? What that really means is 2/1. Right? So even if we're just given a whole number slope, we have to think about that as a fraction. So now I can flip that. Right? The opposite would be negative, and the reciprocal would be 1/2. Right? So if I give you something like -7 as my slope, well, again, we have to think about that as -7/1. So its opposite reciprocal would be positive 1/7. All right? So today, then, we're going to use those two ideas to write equations of lines that are either parallel or perpendicular. Okay, so in this first example, what we want to do is write an equation of a line that goes through the point 8,2 and is perpendicular to this line right here. All right? So we always want to look at whether we are finding a parallel line or a perpendicular line. Okay, here it says perpendicular. That tells me I want the opposite reciprocal slope of the line in question. Okay, well, if I look at this line, or at this equation of the line, right off the bat, I can see that its slope is -1/2. Right? Since this is in the form y equals mx plus b, my m is right here. That's my slope of this line. But if I want a line that's perpendicular to that, I need to take the opposite reciprocal of this. Okay, so this slope is negative. That means my new slope will be positive. And the reciprocal of 1/2 would be 2/1, or just 2. So I want the equation of a line with a slope of +2 that goes through the point 8,2. Okay, now this becomes a problem just like what we were doing. Right? You can either use y equals mx plus b, or you can use y minus y1 equals m times x minus x1. Right? I'm going to do y minus y1 equals m times x minus x1. Right? So this is my m, this is my x1, this is my y1. Just plug them in. So y minus 2 equals 2 times x minus 8. And then we want to solve for y. So distribute this 2 through. So y minus 2 equals 2x minus 16. Add this 2 over. And my final answer is y equals 2x minus 14. Right? So this is the equation of a line that is perpendicular to this one that goes through this point. Right? So let's take a look then at an example where we have to find an equation of a line that is parallel. Okay? We want parallel here. All right? So parallel tells me I want the same slope as the line in question. Right? Now, just looking at this example here, this equation, it is not in slope-intercept form. It is not in the form y equals mx plus b. Right? The y isn't by itself. So sometimes we will have to solve for y first. Okay? In order to just know the slope, looking at an equation, y has to be by itself. So in this case, what I have to do first is add 3x to both sides. Okay, that'll get my y by itself. So I end up with y equals positive 3x plus 1. Now I can just look at this equation and see the slope. Okay, the slope then would be positive 3. Right? I know a lot of you would be tempted to just look at this equation and say, well, the slope's negative 3. Right? We can't do that unless y is by itself. Okay, once we get y by itself, then I can say my slope is 3. And we want the same slope. Right? If we're looking at a line parallel, we want the same slope. So the slope of my new line will also be 3. And I want it to go through this point. Right? Since I did point slope form on the last example, I'll do slope intercept on this one. Right, so here I'm going to plug 3 in for m, negative 1 in for x, and 5 in for y, and solve for b. So 5 equals 3 times negative 1 plus b. So 3 times negative 1 is negative 3. Add this 3 over, and I get that b is equal to 8. Okay, so remember, that's not the final answer. I still have to use these two pieces of information then to write the equation of a line. So my slope is 3, my y-intercept is 8. So the final answer then is y equals 3x plus 8. So I want you guys to pause the video now and take a look at the first two problems here. Okay, see if you can figure out the first two problems. All right, number 1, we're finding a line parallel, and number 2, we're finding a line perpendicular. All right, so take a second and try to figure those two out. All right, let's go through these real quick here. You should have already paused the video and tried these on your own. All right, so here I want a line parallel. Parallel means same slope, so the slope of this line is 1/2, meaning the slope of my new line will also be 1/2. And I want it to go through the point negative 4, 2. So y minus y1 equals m times x minus x1. Plugging in my y1, my m, and so here I'll have x minus negative 4, which is the same as x plus 4. Distribute this 1/2, 1/2x. Now 1/2 times 4 you can put in the calculator if you're not comfortable with that. That is just plus 2. Then add this 2 to the other side to get y by itself. And we end up with y equals 1/2x plus 4. Right? So that's my final answer. That's the equation of a line that is parallel to this one that goes through this point. Right, let's take a look at number 2 here. Okay, number 2, we want a line that's perpendicular. Right? So here, my old slope was -3 over 1. Right? And remember, if we've got a whole number, we always want to think about that as over 1. So my new slope, my perpendicular slope, will be positive 1 over 3. And I want my new line to go through the point 3, 1. So y minus y1 equals m times x minus x1. Distribute this 1/3, so I get 1/3 x. Now 1/3 times -3 actually ends up just being -1. I will add 1 to both sides then, and I get y equals 1/3 x. Now -1 plus 1 is just 0. So you can write the plus 0 here, but you don't have to. You can just leave your answer as y equals 1/3 x. Alright, so let's take a look at something that might be a little bit different now. Alright, so on numbers 3, 4, 5, and 6, well actually 6 is a little bit nicer, but on numbers 3, 4, and 5, okay, we've got problems set up slightly differently. So on number 3, we want the equation of a line that goes through this point that is parallel. Okay, so parallel tells me same slope, okay, but I'm not given an equation. All I'm given is we want a line parallel to the line that goes through these points. Well, I can find the slope of a line that goes between these 2 points, right? We know how to do that. We know that our slope formula is just y2 minus y1 over x2 minus x1. So y. All right, so I can label my points x1, y1, x2, y2, and plug them in. So -3 minus 1 over 2 minus 4. So -3 minus 1 is -4. 2 minus 4 is -2. And now this does reduce. -4 over -2 is actually just positive 2 over 1, right? Because a negative divided by a negative is positive. So now we're to the point where we were in numbers 1 and 2. We have our slope, we have our point. So m equals 2. I want it to go through the point 1, -1. So y minus y1, now here y1 is negative, so that would be y minus a -1, which will be the same as y plus 1, equals 2 times x minus 1. Distribute this 2, we get y plus 1 equals 2x minus 2. Subtract the 1 over, and y equals 2x minus 3. Right, so that's the equation of a line parallel to the line that goes through these 2 points. Right, now, on numbers 4 and 5, okay, the only difference is our lines, the equation of the lines that we're given is not in slope-intercept form. Right? We said in order to find the slope of our old line, we had to first put it in slope-intercept form. That means solve for y. So I need to solve this for y first. I'm going to subtract the 2x over, so I'll have -y equals -2x plus 4. Okay, remember, these aren't like terms, so I can't combine them. And I still have that negative sign out in front of the y, so I'm going to divide everything by -1. And that'll give me y equals positive 2x minus 4. So now I can see that the slope of this line here is positive 2. But I want a line that's perpendicular. So that means I want to take this 2 and take the opposite reciprocal of it. So the opposite reciprocal of positive 2 over 1 will be -1 over 2. And I want my line to go through the point 8, -6. So y minus y1, so that'll just be plus 6 equals -1/2. times x minus 8. Distribute this negative 1/2, so negative 1/2 x. Negative 1/2 times negative 8 would be plus 4. Subtract the 6 over, and we get y equals negative 1/2 x minus 2. All right, so I want you guys to again pause the video and try number 5. It's a similar idea, okay, where we first need to solve for y. This is not in slope-intercept form. So the first thing we need to do is get this into slope-intercept form. Right, so go ahead and do that. All right, let's take a look at this one together then. So first thing I want to do is subtract x over. I'll get 5y equals negative x plus 6. Then I want to divide everything by 5 to get y by itself. So we end up with y equals, now this negative x over 5, right, is the same as negative 1/5 x. Then I can just leave this plus 6 over 5. So now, just looking at this equation, I can see my old slope is negative 1 over 5. But this tells me I want perpendicular. Perpendicular means I'm going to take the opposite reciprocal slope. So my new slope is going to be positive 5 over 1, okay, or just 5. And I want my new line to go through the point 2, negative 2. So y minus y1 equals m times x minus x1. So y1 is negative 2, so this will be y plus 2 equals 5 times x minus 2, and solve for y. So distribute this 5, we get 5x minus 10, subtract this 2 over, and we will get y equals 5x minus 12. All right. One last example, and it is another perpendicular example. So here, this is already in slope-intercept form. Right, so perpendicular tells me that I want a line with the opposite reciprocal slope. So here the slope was positive 4 over 1. That means my new slope will be negative 1 over 4, and I want it to go through the point negative 2, 1. So let's see, I've done a lot of examples using point slope, so I'll do this one in slope-intercept. Right, y equals mx plus b, and remember, it is entirely your choice. You can choose which method you want to use. All right, so this is my m, my x, and my y. I'm going to plug all of those in. So 1 equals negative 1/4 times negative 2 plus b. So negative 1/4 times negative 2 is actually positive 1/2. So now I want to subtract this 1/2 over, and 1 minus 1/2 is just 1/2. So then I have my b, I have my m. The equation of my line then will be y equals negative 1/4 x plus 1/2. All right. So now that you have finished the note sheet, you can go ahead and move on to the practice assignment.